Okay, day 3, we're going to look at functions, domains, ranges, x and y intercepts. So a function is a relation in which every input has exactly one output. Basically meaning for every x, there's only one y. Your input is your x, your output is your y. To be a function, a graph must pass the vertical line test. So, example of a function, you get a parabola, opening up, opening down, horizontal line would pass the vertical line test. Let's say a cubic root function, cube root function. Your 1 over x function, like if you think of that, there's asymptotes, but then it goes like this. That would pass the vertical line test. Something that would not, a vertical line is not going to pass a vertical line test. A circle is not. A sideways parabola would not. Something that looks like this would not. Determine whether each of the following is a function or not. Explain your choice. So let's say you have something where, it's not graphed. You're not given the graph. If we think about this, if I solve this for y, when I put a value in for x, I'm only going to get one y value for every x value I put in. So yes, only one y for every x value. Now, in B, since it has the plus or minus, I'm going to say no. There'll be 2 values of y for some, or for, I guess I say most x values, really all x values except for like if you put 0 in for x. Or no, you put 0 in for x, you'd get plus or minus 3, right? So something that would make that work out to be 0, you wouldn't have plus or minus 0. So, yeah, I guess I'll just say for some. As soon as it happens for more than 1, then it's a problem. The next one, if I went to solve for y, when I square root in an equation, I would need plus or minus. So that's the same thing. No 2 values of y for some x value. D is yes. Only one y value for each x value. And in this one, let's see, -2 is corresponding to 4, but it's also corresponding to 6. So no, -2 corresponds to both 4 and 6. So basically 2 different y values. For function notation, for functions, x is the input and f of x or y is the output. So it says evaluate f of 2. Well, f of 2 means you're going to put 2 in wherever you see an x. F of negative x means put a negative x in everywhere you see an x in the equation. So everywhere I see an x up here, I'm putting in negative x. So that'd be x squared minus 3x plus 5. Negative squared is a positive. This one means put an x plus 3 in everywhere you see an x. So it'll be x plus 3 squared plus 3x plus 3 plus 5. X squared plus 6x plus 9 plus 3x plus 9 plus 5. Just distributing. So it's x squared plus 9x plus 18 plus 5, 23. Negative f of x just means to negate your f of x. This is my f of x, so I'm negating x squared plus 3x plus 5. So I'm getting negative x squared minus 3x minus 5. F of x plus h, that's putting x plus h wherever you see an x. So it would be x plus h squared plus 3 times x plus h plus 5. Oops, x plus h squared, not cubed. So I'm, again, plugging into this up here. Wherever I see an x, I'm putting an x plus h. So this would be x squared plus 2xh plus h squared. I'm getting that from, I could come off to the side and FOIL this and see it's x squared plus 2xh plus h squared. Then I'm going to distribute the 3, so it's 3x plus 3h plus 5. So this is x squared plus 2xh plus h squared plus 3x plus 3h plus 5. So really, I guess I didn't even need to rewrite that. That's our f of x plus h. So now for f, the difference quotient says to do f of x plus h minus f of x all over h. So I already did f of x plus h. That is x squared plus 2xh plus h squared plus 3x plus 3h plus 5. Minus f of x, which the original f of x is up here again, where I have it circled, the x squared plus 3x plus 5. So as soon as you have to subtract more than one term, you've got to put it in parentheses, x squared plus 3x plus 5, and then all over h. So x squared plus 2xh plus h squared plus 3x plus 3h plus 5. Distribute the negative, so it's minus x squared minus 3x minus 5 all over h. X squareds cancel, 3x and the negative 3x cancel, 5 and the negative 5 cancel. On the top, you pull out an h. Bottom, there's an h. That way we can reduce, and we have 2x plus h plus 3. Okay, so the next one, f of x plus h, this would be negative 3x plus h squared minus 2x plus h. You're putting x plus h in for x. So this is negative 3 times x squared plus 2xh plus h squared minus 2x minus 2h. Distribute your -3. Okay, and no like terms to combine, so that's it. Now, when we have the f of x plus h minus f of x over h, well, I already did f of x plus h, right? I've got this answer. Minus f of x, which is the original -3x squared minus 2x, all over h. Okay, on the top, I factor out an h. Cancel the h's, and this simplifies to -6x plus h minus 2. Okay, domain of a function is all possible x values that will output real y values, and the range is all possible y values that correspond to real x values, or we could say inputs. All right, so for domain of the following function, right, so we have that red line there. So -infinity going over to 1. Then there's a little break. And then we're going 2 to 5. Oh, I think that's a dot at -5. So wait a minute, not -infinity. We want to go -5 to 1. And then there's a break, 2 to 5. I didn't notice that's a closed circle there on -5. The range is going from, let's see, our lowest y is -2. And then, like, I usually like to, like, if I'm going through for the range, I think of going through horizontally and making sure I'm hitting every y value. So I am hitting every y value up to a y value of 4. With the domain, I kind of think of going through vertically and am I hitting every place? Well, here, no, I'm not hitting anything between 1 and 2. Okay, next one, domain. There's an arrow on the end, so we will say -infinity. We do have an x at -2. That's that closed circle. We don't have anything at -1. Then we go -1 to, they're trying to show here at 1 that there's like an asymptote. So to 1, and then 1 to infinity. Range, we're going 0 to infinity. So it's kind of looking like they're showing there's a horizontal asymptote at 0, and then we have every y value accounted for onto infinity. X-intercept goes through the x-axis. So we know that y is 0, and a y-intercept goes through the y-axis, so its x value is 0. So if we were to find the x and y intercepts, x-intercept, let y equal 0. So if I were doing an x-intercept here, I'm going to let the y be 0, which is this. So I'd say 0 equals 4 square root of x plus 1 minus 8. Add the 8. 8 equals 4 square root of x plus 1. Divide by 4. 2 equals square root of x plus 1. Square both sides. 4 equals x plus 1, which means x is 3. That's your x-intercept. So you can just say the x-intercept is 3, or you could say 3, 0, either one. If they said coordinates, then you would have to say the 3, 0. Now for a y-intercept, you're going to let x equal 0. So it would be 4 square root of 0 plus 1 minus 8. 4 square root of 1 minus 8. 4 times 1 minus 8, negative 4. So we'd either say negative 4, or we could say 0, negative 4 is the y-intercept. X-intercept here, let y be 0. So if I were solving that, I would say times 8 times 8 minus the 3 negative 3/7. If I were doing the y-intercept, I would let x be 0. Y is 3/8. And I think that's it. Yep, that's it.